everybody. You know who this is. Yep, and here we go again. Today we're going to do some problem solving using the Pythagorean Theorem. I will tell you right now that the number one thing you can do to help yourself succeed is when you're reading a word problem and you realize that something you can look at is being described, you need to create a diagram. You probably wouldn't even realize that this was a Pythagorean theorem problem until you do draw the diagram. So let's see what this one has to say. A soldier is marching with her company. From the base, they march 4 miles east and 5 miles south. If they then return directly to the base, how much farther will they travel? So the first thing when I have these direction problems is I'm going to make a little compass rose. So I've got north, east, south, and west. So a soldier is marching with her company from the base. I'm just going to call that here. They march 4 miles east, so they went 4 miles that way, and 5 miles south, and they went 5 miles that way. If they then return directly to the base, like that, how much farther will they travel? So when you go from due east to due south, you are taking a right angle turn. Now can you see our right triangle? What side is missing? I'm going to draw that arrow like we did yesterday from the right angle symbol. So I know that what's missing is the hypotenuse. So here we go. You guys are old hands at this part of the problem. Once you get that diagram written. So we know we're missing C. And here we go. So 4 squared plus 5 squared equals C squared. 16 plus 25 equals C squared. 16 and 25, 41. And when I take the square root of 41, I am going to get approximately 6.4. So how much farther did this company of soldiers need to march back to their base? They had another 6.4 miles to go. That is a lot of marching. So you know that you've got all this stuff copied down. You don't have to copy the written problem. I'm not concerned about that, but I do want to see the diagram on your work, and I do want to see all of this. Let's look at sample number 2. It's very, very similar. A plane takes off and heads 10 miles north. It turns and heads due west for another 5 miles. How far is the shortest route back to the airport? So let's see. I'm going to do my compass rose again. North, east, south, and west. So here's my plane. I'm going to put it at the center there. It goes 10 miles north. It then heads due west for another 5 miles. How far is the shortest route back to the airport? So again, when you change directions like this, you are changing directions at a right angle. So what's missing? I wish I had put this 10 on the outside of the triangle because it's a little confusing. What's missing, again, is the hypotenuse. So we know that 5 and 10 are A and B, the legs. So 5 squared plus 10 squared equals C squared. 25 plus 100 equals C squared. 125 equals C squared. And the square root of 125 I didn't do this. I didn't get this answer before. Square root of 125 is approximately 11.1. So I need to add my unit here. Gosh, I don't think I did that on the last problem. I'm going to go back and fix that. So if the question is how far is the shortest route back to the airport, the answer is 11.1 miles. Make sure you have all that down. Again, you don't have to copy the problem, but you do have to copy the diagram, and you do need to copy all the work. I want to scoot back to our soldier problem for a second because I neglected to put the unit on that. Again, we're talking about miles, so it would be 6.4 miles. That is a long march. Okay, so there are samples 1 and 2. Let's see what I did with sample number 3. It is right here. So this is a little bit different, but the exact same type of problem. So a dancer is standing in the corner of a stage that measures 40 feet by 32 feet. If the dancer crosses the stage diagonally to the opposite corner, what distance has he moved? So again, if the problem is describing something you can see and you are not given a diagram, you need to make a diagram. Doesn't have to be beautiful, doesn't have to be to scale. Let's see, it measures 40 by 32. So I've got 40 and 32. If the dancer crosses the stage diagonally to the opposite corner, and it wouldn't matter which diagonal you chose here, what distance has he moved? Now, this is another Pythagorean theorem problem that it's kind of hard to recognize that that's exactly what it is. But if you're on a rectangular stage, you know that these are right angles. If I cover up that half of the stage, does it make it easier to see that we really do have a right triangle here? So when you are asked about the diagonal of a square or a rectangle, it is almost always a Pythag problem. So here we go. We are copying our formula. A squared plus b squared equals c squared. Let's see, the hypotenuse is again what's missing because I draw my arrow from the right angle symbol to that side right there. So let's call A 32 and B we can call 40. So 32 squared plus 40 squared equals c squared. Let's see. So 32 squared is 1,024 plus 40 squared is 1,600. When I add those two together, I have 2,824 equals c squared. Again, I must take the square root of both sides to be done. So c is approximately, if you do the square root of 2824 on your calculator, and I just want to double check mine, square root 2824, that is not right. Try one more time. Square root 2824. Yep, and that comes out to be about 53. And let's see, our unit will be feet. Just want to check that math again one more time. I knew I did something wrong. Did anybody catch this? Let's see, this should be a 6. And I apologize for making the mistake. That should be a 6. And when I do the square root of 2624, I get 51, and I apologize for that. But, you know, it just goes to show that even someone who's writing out all the work and being very careful can make a mistake. So 51 feet is our answer here. And let's look at sample 4 now. And now you're probably saying to yourselves, why don't you just do the video over? The reason I didn't do the video over and I left the mistake on is that it takes me so long to make these, and I just don't have it in me to make a new video on this today. So forgive me. Let's look at the next one. A rugby field measures 106 by 68 feet. If a player runs from one corner to the opposite corner, how far did that player run? Alrighty, so let's take a look at the field. Again, if something is being described that you can see and you're not given a diagram, you have to draw it. So I've got 106 and 68. And it says, if a player runs from one corner to the opposite corner. So he or she could start at any corner, or say this one, and runs to the opposite corner. How far did the player run? Again, if you cover up the other half of that rectangle, you can see that we've got a right triangle here. So let's do a squared plus b squared equals c squared. What's missing here? That's right, it's the hypotenuse. So we've got 68 squared plus 106 squared equals c squared. 68 squared is 4624 plus 106 squared is 11,236. When I add those two numbers together, let's see what I get. 4624 plus 11,236. C squared equals 15,860. Gotta have C all by itself. C squared is, I'm not done when I've got C squared. So I'm doing the square root of 15,860, and I get 125.9. So C is approximately 125.9. And let's go back to the problem to find our unit, and it was feet. 125.9 feet. And there we go. Let's take a look at your independent problems. I want to make it very, very clear that you must draw a diagram of each problem. And let me read these to you. You don't have to copy down the writing, but you do have to draw a diagram, and you do have to show all your work. Okay, so here's problem number 1, and it says, a plane takes off from the airport and flies 3 miles east. The plane then travels 4 miles due north. If from there, the plane travels directly back to the airport, how much farther will the plane fly? So this is one of those direction ones where you want to start by drawing the compass rose. And here's your second independent problem. A World Cup soccer field must be at least 110 yards long and 70 yards wide. On a field this size, what is the diagonal length of the field from one corner to the opposite corner? So this is review, kids. I want you to have confidence in yourselves that you do know how to do this and you can do this. As always, let me know if you have questions, and I really do hope I see you soon. Take care.